All right, we today will be investigating outliers and how to deal with them. So you'll know that you're successful if you can find values that are outliers, investigate their source. So like, why did we have a random extremely high number? Why did we have an extremely low number in a particular survey? And figure out what to do with them, whether to eliminate them or keep them. If you can tell how an outlier will impact the mean, median, IQR, or standard deviation, then you are successful for today's lesson. I'm recording it right now. I'll link it in the slides. This honestly is a pretty easy lesson. I've taught it the same way for the past 3 years, but they want us to use this new curriculum, so I have to use it. If you want like just a really straightforward to the point breakdown, feel free to watch this. It's in the slides. All right, I made it super easy. But I'm recording a different way of teaching it and we'll go through it together. The practice is a puzzle piece, lesson 14. And we went over this yesterday. These resources are available in Schoology right now, right at the top of your algebra course. And it's to prepare you for your Unit 1 test, which is next week on Thursday. So binder check will be the day before that. And deadline for late work from Unit 1 normally is the same day as the test that I'm giving you till Friday. And based on the feedback I got from all my classes, I am going to be making this study guide a 100-point homework grade. All right, so it's just 14 questions.
What do you mean 100 points? You mean like, if I get an F on that, that means I'm gonna throw my grade to an F.
No, it's in your homework category, which is only 10% of your grade overall.
Oh,
Say you did all your practices so far, I don't know how many of them. Let's just say 14, even though there's less than 14. So let's say you have 100% in your homework category right now. Not doing this would probably bring it down to like a 50% in that category, bringing it to like a 5% difference. But if you do it, then that really drowns out any missings you had. It prepares you for your tests, and I want you to do it, so that's why I'm making it 100 points. Questions on that? And it's available now. There's 14 questions. It's made to the test. So by scoring high on it, it's a good indication that you will also score high on your test. Questions on that? All right, so then other things like that Quizlet I showed you that you can use to study and just, make sure that you're ready for Thursday. All right, to the notice and wonder. Again, the note sheets aren't perfect. I didn't make them, but like I'm already spending so many hours planning. I don't have time to make ones that are perfect. Okay. We just gotta work with what we have. So just somewhere at the top of your paper, you should have wrote some things that you noticed and some things that you wondered. So what are some things that we noticed about these two displays? Yes. Both numbers 1 through 10. Both numbers 1 through 10. Anyone notice something different? Yes, can you just spread out from the beginning? Okay, so would you say that it's pretty spread out, that it's pretty close together?
there's one that's pretty close together, so this one, and then to the other side, they look more spread it, more in the far apart.
Okay, so it looks closer together on histogram. Spread out on box plot. Yes. Yes. So both are considered right skew. All right, it's pretty easy to tell the direction of the skew on like histograms and dot plots. So remember, you look for like the void. So this is right skewed because the void is on the right. I understand why box plots can be trickier for students, but you just have to remember, your quartiles split your data into quarters. So like, here's the first 25% of my data, here's the second 25%, here's the third, and then here's the fourth. All right, so you can see that even though like they're all equal parts of the data, this one is bigger because it's more spread out. All right, so that means there's fewer, I don't know how else to describe it. It's more spread out, so there's a bigger gap here if we were to make a dot plot. So it is still right. Questions on that piece of it? Why it's like two? Anything else that we noticed? There's one thing that I'm looking for that so far no one has said. Think about our goal for today. There's a potential outlier. I'm gonna write that on the sleeve on the bottom. All right, outliers are what we call extreme values. Like they might be extremely high compared to the rest of the data, they might be extremely low compared to the rest of the data. So there's a potential outlier there. What are some things that we wonder? Anything? So why is the outlier there? Anything else? All right, we actually do have titles for these graphs today. It's per capita health spending by country. So this is how much in thousands of dollars that country spends. And it's per capita, which is like a weird thing, but it's kind of like per group of people, like per population. So this would represent maybe a country spending significantly more than the rest of the other countries. So we could ask like, what country is that? Things like that. Anything else anyone wants to ask? All right. So continuing on with this situation, so still the same box plot and histogram. These show the average amount of money in thousands of dollars spent on each person in the country for healthcare in 34 countries. So we kind of mentioned this before. One value in the set is an outlier. Which one is it? What is the approximate value? So in the histogram, it's debatable because in this column can be 9 through 10. In the box plot, it should be easier to see. What's it close to? 10. All right, so the approximate value for our outlier is 10. And then this is worded weird, but it says by one rule for deciding a value is an outlier is if it is more than 1.5 times the IQR greater than Q. All right, I know that's not easy. Let me show you a formula that I think is easier to comprehend. And you're gonna write it toward the top of your paper, maybe like star it, highlight it. All right, but here it is, the formula that I want you to write. So a data value X is an outlier, and I'll write it a little bit bigger here. If X is less than Q1 minus 1.5 times the IQR, or if X is greater than Q3 plus 1.5 times the IQR. All right, so what do these two formulas have in common? Yes, Camille?
So 1.5.
The 1.5 and the IQR. Anything else they both have in common? Right, they both have an X in it, so X would be like whatever data value you're testing. So if we're talking about the warm-up, we would be plugging in 10 for the X, so we're testing to see if 10 is an outlier. So that's what they have in common. What do they have that's different from each other? Camille, yeah?
The sign and the
So the fact that there's a Q1 in one of them and a Q3 in the other one, and which signs are you talking about? Greater than and less than, and then of course this last piece, one has a minus sign, one has a plus. So these formulas I think make it super easy. I have been strongly discouraged from letting you use notes on the unit test, so we can't do that. This would be something that you have to memorize. Hang on 1 second. If it's like 1.5 times the IQR away from the quartile, then it's an outlier. So if I'm testing a value that's much smaller than the data, and this is like a different situation, but just bear with me. Like if I'm testing to see if 1 is an outlier, I would plug in 1 for the X. I would plug in Q1, which for this one looks like it's 9. And then minus 1.5 times the IQR. What's the formula for IQR? Good, which I can also tell from my box plot. What's my Q3 in this one? 13. So then you do in the parentheses 13 minus 9. And then depending on whether that's true or false, if it's true, then it's an outlier. If it's false, then it's not an outlier. And then if you're testing a value that's much bigger than the rest of the data, then you use this other equation. So you'll know because if it's the lower value that you're testing, you use the lower quartile. If it's the upper value that you're testing, then you use the upper quartile. Questions on that? All right, this is a good visual. I've never seen a visual representation, but like in this situation, they did the 1.5 times the IQR. So like the spread of that box, they did 1.5 of it and measured out. So anything like beyond this is an outlier. So is 17 an outlier? No. Is 23 an outlier? Let me see where this falls exactly. It looks like it falls on the 19. Is 19 an outlier? It is not an outlier because the expression might look something like this. 19 greater than 19. Is 19 greater than 19? No. No, so 19 is not an outlier. Let's see over here for like the lower threshold. Is 7 an outlier? Or sorry, we're looking up here. Is 7 an outlier? No, because it's within the 1.5 times the IQR. Is 1 an outlier? Is 2 an outlier? Is 3 an outlier? No, because the expression would look something like this. Because you have to do this one. Let's do the math to get is 3 less than 3. So that one would not be done. All right, so that tells you like these formulas tell you the threshold of when it becomes an outlier versus when it doesn't. Let's do a few examples. And the example that we're going to do, we're going to use technology. Because do you want to solve the mean for this by hand? No. No. So we're going to use technology. So pull up the Desmos Calculator, since that's the one you have access to on your test, unless you have your own graphing calculator that you'd rather use. And this data is also printed on your notes. So because it's like small, you don't have to look at the screen. You can look at your own notes. And we're pulling up the Desmos Calculator. Just start getting in the habit of finding it. So like open up a new tab and go to desmos.com. It is in one of the folders, but I'd rather you just know where it is all the time. Okay. And it's been like, I don't know, a day since we learned how to use this to find all these different values. So if I want to input this data set into Desmos, what do I do first? They are all in order, and that's not necessary. Put something like A equals. So you want to name your data set. Let's call this data set A. I think the only letter that doesn't work so far is E. All right, so just pick A. And then what do I press after pressing the equals? Good, so that's right next to the P, the square bracket that you should use. And then you're literally, and everyone's been getting kind of annoyed with me, but this is easier than finding it all by hand. You're literally going to type in all your data. So like the 1.0803 comma. These over here are decimals, so make sure you put a decimal. Separate your numbers with commas. And then type them all in. You want to do this part correct, because guess what happens if you mess up a number? You may get it wrong. So that's why you just pay close attention to detail. Don't get frustrated and then just exit out of it, because you can always go back and like edit it. All right, so just take a couple minutes, not a couple minutes. Take a minute and type in all your data. All right, but you don't want to like just hit the exit because you're getting frustrated. You can literally click and then on your right arrow, scan your list, see that you entered the numbers right, see which one maybe you missed. Sorry, I know which one I missed. It's the very last one. All right, and then just enter it. So like, use commas to separate your numbers. Make sure you put the decimal. Should have 34 data points. Like if I want to find the mean, what do I do? Yes, Camille?
You click on the keyboard on the bottom and push function.
Click on the keypad, press functions, then
Scroll down to
good, that's the unit that we're on. And since I'm trying to find the mean first, I could click mean. I could also just type it in too. All right, but some of them are coded kind of funky. But you press mean, and then in the parentheses, you don't have to retype all your data. I saw someone do that earlier. Because you typed it up here, you can just put A. And look, there's my mean, super easy. Yeah, we did this the other day. Don't you guys remember?
yeah, but I didn't remember you could have done it like that.
You can, and I don't consider it cheating because you can take a graphing calculator to the ACT, and if you know how to use your graphing calculator, they can usually do that stuff too. Only thing is, on like those short answer questions that are on paper, if it says show your work, then you need to show your work. Don't just say I use the calculator. All right, but yeah, so like my mean, I'm gonna write that in my paper because that's on your note paper. So you want to write that down. I'll write it up here because I need a lot of room. All right, but my mean, and then since they round their data to 4 decimal points, I'm gonna round mine mean to 4 decimal points. So you guys know how to round? All right, if you don't, since I'm rounding to 4 spots, underline like the 4th spot. It's not really letting me right now, but underline the fourth spot and then look to the right of that number. So my fourth number is 9, to the right is a 4. If it's 0 through 4, then the fourth spot stays the same. If it's 5 through 9, then it moves up. But to the right of the 9 is a 4, so that's 90. All right, you guys remember how to find standard deviation? All right, so then in a separate box, do these all in separate boxes, and you'll see why later. But go to your function, find standard deviation, and this time we're going to do the one of the population, since we're talking about a population type problem. And then type in whatever you named your data set. So we named it A. And then my standard deviation pops up. We're using the one with the P right now. So we're talking about population. Question. If you're not getting these numbers, maybe you messed something up in your list. So just check it out. It's not a big deal. You can search through your list by clicking and then right arrow scrolling through. And then I don't know what to tell you. It's on your paper, right? Well, take down these numbers so that way when you look at it later, you know how to find it. Or that you know you did it right. All right, but there's my standard deviation. Other thing it wants is the 5-number summary. What's that? Q1, Q3, what else? We already found the mean, and that's not part of the 5-number summary. These 3 are, what else? Minimum and maximum. And guess what? Desmos has buttons for all of those things too. And then all you have to do, say we're wanting to find even just our minimum, Desmos can also find that for you. So like press min, type in A. And look, there's my minimum. Did I really need the calculator to tell me that? No, but it makes sense. So my minimum is 1.0803. Find the rest of the 4 things. So maximum, you should have had 9.8923. Q1, what did you guys get? So that one, you press quartile, make sure you don't press quantile, we're talking about quartiles. And then those ones enter a little bit funky, like I need to put an A there, but then nothing pops up, so what do I do? Comma, and then whatever quartile you're trying to find. So like if I'm trying to find the first quartile, I'll put A, 1, which is 2.1495. Do the same for quartile 3, and I'm going to put them all in separate boxes because you'll see why later. All right, quartile, lowercase a, to find quartile 3, should have been 4.8398. Median has its own button, but also what quartile is the median? Quartile 2. So if you want to use the quartile button, go ahead. If you want to use the median button, that's fine too. All right, but my median should have been 3.4904. Questions on how we found any of that? All right, jot them down on your notes, the values. So that answers the first question. Use technology to find the mean, standard deviation, and 5-number summary. Number 2 says the maximum value in this data set represents the spending on healthcare from the United States. So should the per capita health spending for the United States be considered an outlier? So they're asking, should the maximum be considered an outlier? What do you think? Potentially, how can you know for sure? Use one of the 2 formulas. Which formula do I use? Hopefully you wrote them on your paper. Do I use the one with the Q1 in it or the Q3? Oh, the Q3, because the maximum is closer to the Q3 than it is the Q1. That's why you measure it that way. So here's that formula again, but just for the Q3, I'll show you. Sorry, doesn't want to. Okay, all right. So that formula is x greater than Q3 plus 1.5 times Q1. So it's an outlier if the number is greater than the Q3, which we said is 4.8398 plus 1.5, and then I'm out of space. I'm going to put it times the IQR. What's the formula for IQR? Q3 minus Q1. I could just do it separately and then just plug it in. I'm just gonna write the whole thing in there. Calculate do the work. So Q3 minus Q1. So 4.8398 minus 2.1495. Close parentheses. And to the right of the inequality is what I'm going to put in my calculator. I just gonna fit it on the same line. So that whole thing I'm gonna put in the calculator. All right, so type it in 4.8398 plus 1.5 parentheses 4.8398 minus 2.1495. All right, all I did was type in what I highlighted in the green and look at the number that it spits out. Is this number, so the number we're typing is that, is this number less than the 9.8923? Yes. Let me word it differently. Is 9.8923 greater than 8.8753? So is the 9.8923 an outlier? Yes or no? Yes, this is an outlier. All right, so all that work to tell me if it's an outlier for sure. Because I have seen questions on tests where the number really isn't that far away from the data, but it's still an outlier. Because it's above that threshold. All right, so this right here is an outlier, and we proved it by using the formula that should be at the top of our number. Questions, comments, concerns? All right, let's do one with easier numbers. The one that we'll do is on cool down, if you want to start getting that out. But there are a few questions I want to answer together. I don't know if they're printed on your page. Oh, also real quick, let me show you this. One other piece says like what happens if we remove the outlier. So I'll just show you on Desmos real quick. If I go back up to my data, I'm not going to exit it out and start all over again. I'm just gonna find my maximum, my outlier that I had, and remove it. And then you can see how it changes everything else. All right, the mean decrease because we took away a really big number. The standard deviation decrease because we're getting rid of a number that was super far from the rest of the data. And so forth. The maximum changed, the minimum did not. The quartiles changed because we moved like where the middle is when we took away a data point. All of that you can see by comparing your data. All right, but let's answer these questions first. I don't think they're printed anywhere, so let's just talk about it. What is an outlier? In your own words, what's an outlier? Anyone other than Camille? She's been doing all the work for you guys. It's a number that is far from most of the data. All right, sometimes we call it an extreme value. So it could be extremely high, it could be extremely low compared to the rest of the data. Why are outliers important to notice for a data set, like in the real world, you think, Gavin? Good. It can skew your data. Like, I don't know, I'll use the healthcare example again. If the United States is trying to say that on average, they spend about 3 point whatever thousand on healthcare, would that be true? No, they spend a lot more than that, but if they're trying to use that data to support that, then that would be misleading. So it can skew data, it can be misleading. It could show like where errors were made in the collection of the data. So it's important to notice those things. How do outliers affect measures of center? So like the mean. It kind of just depends on whether the outlier is a lot bigger than the data or a lot smaller than the data. So if the outlier is an extreme low, would you expect it to increase or decrease the mean? To decrease the mean because you're adding a really small value to the top. If it's an extremely high value, would you expect the mean to increase or decrease? Increase. Now you're putting a big number on the top. All right, how do they affect measures of variability? So like standard deviation, for example, things that measure spread. Do outliers increase or decrease standard deviation? Increase. So outliers increase standard deviation. Removing outliers would decrease the standard deviation. All right. Reasons why you'd eliminate an outlier could be like to have the data be more representative of the population. All right, now to the pull down. That is on your paper. Feel free to use your technology and answer those questions. Actually, what's on your paper is just these two questions. All right, but the data is up here. So try that out. If you finish early, you can start your puzzle piece. We'll go over this answer in, I'd say 2 minutes-ish. 1. And did you just eyeball it and assume, or did you do the math and figure it out? Well, in this one instance, you are right. It is a outlier. To tell for sure, you should have used which formula? not equals. Is it greater than or less than? Well, if we're testing the 21, is that much greater than the data or much less than the data? Then you should use the greater than, and then Q3 or Q1, because it's closer to Q3, and then plus or minus. Good, and then the 1.5. If you do that, just like how it is on your homework, so put this for X, because that's what you're testing. It tells you your Q3, which is 2.5, it tells you right there. Plus 1.5, and then you have to figure out your IQR, which hopefully isn't very hard. What's the formula? So then take Q3, which is 2.5, minus Q1, which is 0.5. I'm sure you can probably even just do that chart in your head, but I'm still gonna leave it like that. Enter this in the calculator. Whoever's singing, can you please stop? Thanks. 2.5 plus 1.5 parentheses 2. I get 5.5. Is 21 greater than 5.5?
Yes.
Yes. So yes, it's an outlier. This can be my reasoning. And then they said, what happens if I change the value of 21 to 1? Because let's say they don't want to include fish as pets. Would that affect the median standard deviation or IQR? Most likely, yes. Let's see what it affects, if I can just summarize it for you. Guys, stop talking. The mean would decrease because we're taking away the really big number. The standard deviation would increase or decrease. Decrease if I'm making it less spread out. I'm taking away the extreme value. And median stays the same. In this one, you would actually have to check. And then my IQR decreases just a little bit, but it decreases if you care to check. The only thing we didn't do today is an example of where it's an extremely low value. So I'll show you in the video where you can find one. And I'll put it on the screen. If you are testing a value that's a lot lower, then you need to, let's see. Like in this one, we're testing the 72 to see if it's a outlier or not. So that's when you use the smaller formula, the one with the less than. And there it is. So 72 less than Q1 this time, which we found by hand, minus 1.5 times the IQR. And then in this random situation, is 72 an outlier?
No.
No, because is 72 less than 67.5? So it's not an outlier. If this number that we were testing was 67, would it be an outlier? Is 67 less than 67.5? Yes, it is. Would you rather have $67 or $67.50? So then, yeah, 67 is an outlier if we were using this situation. What if it was 67.5 that we were testing? Would that be an outlier? No, because it's not less than 67.5. It's exactly that. So that's how you can tell. If it's a lot smaller, use the formula for numbers that are smaller. Good, any questions? Alrighty then. You have the rest of the time to work. Don't pack up until 1:09.